Okay, today we're doing something a little bit different. I've got a problem from the Putnam Exam, 1987. This is problem B1. I read up a little bit on this exam because I wasn't that familiar, and it looks like it's been going on for a very long time, I think back to the 40s. And it's not just integrals, it's actually mostly other things, calculus and anything math. Okay, so let's take a look at this problem, and the thing that jumps out is this is looking, I know we're used to using this typically with trig functions, but I think actually this is a good case where we can use the King's principle. Okay, so for the King's principle, I've done a number of other videos. I have a quiz, I have an introduction and kind of a proof kind of video. So I think what I'll do is provide a link. If you need more information, I'll provide links in the description if you want to check some of that stuff out. And then that way we'll just get right into the problem and move through it. So for our first step, it's going to be a u substitution. And specifically what we want for our u substitution is we want to add the two bounds. So 4 plus 2, 6, minus x. And then we'll also want to get a value for x. So if we just rearrange this, we can find x equal to 6 minus u. And let's just get our dx value. So it's going to be dx is going to be minus du. And then we'll go ahead and make our substitution. So plugging in a 4 here. For our upper bound, we're going to have a 2. And plugging a 2, we get a 4. And you'll just notice that all it did was flip our bounds, reverse the order. And then real quick, before I write this out, let's just find our values for 9 minus x and x plus 3. So 9 minus x is going to be the same thing as u plus 3. Just noticing if we add 3 to this here, we'll have 9 minus x. And then getting a value for x plus 3, that's just going to be 9 minus u. Noticing if we added a 3 here and a 3 here, we have 9 minus u. Okay, so now we'll write this out. We're going to have the square root natural log. Our 9 minus x is going to be u plus 3 in the numerator. And the denominator, this is the exact same value right here. So we'll have natural log u plus 3 plus, and then this x plus 3 one is going to be 9 minus u. And then for my next step, I'm just going to take this minus sign. We could bring it out front, but we're just going to take this and use it to change our bounds. And then from here, what I'm going to do is we're going to do a variable change. we're going to get back to our original integral. So I'm going to put this back in x. We're allowed to change the variable because in a definite integral, the variable name doesn't matter. It's going to come out with the same value when you evaluate the bounds. So we can rewrite this in x. Okay, and then from here, the thing to notice, now we actually have the same denominator exactly with the same variable as we have up here in our original integral, right? Just in a different order. And we've got the same limits on our we've got the same boundaries on our integral. So the key trick that we want to do is we want to take and label our initial integral here as I, but then we just manipulate it here, and this is also I. So if we add these two together, okay, we're just going to have two copies of the integral. We're going to have 2i. Okay, now we've added these two together, just noticing that this first piece is our original integral, just bringing it down, and the second piece is what we found through the manipulations on the last board. So then adding these together, we notice, okay, we got this same denominator, so we can just add our numerators and rewrite this again. And then here we notice our numerator is exactly the same as our denominator. So what happens, this whole thing is just going to be 1, and we've got ourselves a very simple integral. We're just integrating 1 dx. And we know that's just x evaluated from 4 to 2. And so this is going to be 4 minus 2 equals 2. One thing though, that's not quite our final answer because this is two copies of the integral. We'll just divide this by 2, divide this by 2. And so we come up with a very simple answer of just 1. That's it, another fun problem with the King's principle. Again, I'll just provide a link to all the stuff in the description, all the things. So that's it, thank you for watching. Please like and subscribe. Have a great day.